Okay, here we go. So I watched the video solution already to this, but I will continue now with trying to solve this myself. Leetcode goes through a decision tree recursion approach. Before then convolving a top-down approach. And then the bottom-up approach. He does not, does he? He does not speak about the space-optimized approach though, or implement it. But I feel like they should all be similar enough to get right. So I want to try all of these different approaches by first starting off with the recursion. But this can also be solved using dynamic programming, then also bottom-up dynamic programming, and finally the most optimized version is is O of one space using two variables. Hello Rio, very good evening indeed. Thank you for joining. Okay. So I will try this again. I'm going to try and understand this problem by writing it out as well. So we're going to draw, I'm drawing it out. I'm going to create a new drawing, maybe. Yeah, I'll create a new drawing. And then paste it here. And then go to this drawing. Gotta have it open on my iPad now. It's gonna do some stuff. Whoops. You finally started DSA. Starting from the bottom, learning pattern problems, then gonna climb my way up. Alright, sounds good. Sounds like a plan. Make sure to not get too bogged down though in, say, theoretical. Do Leetcode problems along the way. It'll be way more helpful. Personal belief. Let's see. Here we go. Okay. I overcooked with this problem in the sense I spent too long going down the wrong path. So that solution that I have right on your screen is actually incorrect. But it's alright. I think I know how to do this. I just want to visualize this before I do continue. So I'm looking at is this the right time? And yeah, this is okay. So say the problem was 1012. When does your internship start at Amazon, and which office is it going to be? It's going to be starting 2nd of December, and then it's going to be in the Sydney office. That's it. Okay. Now, the way to think about this is in terms of recursively or in subproblems. So we're going to think about the recursive method first. And then we'll think about the subproblem. After. Now it'd be good if it gets updated here. Why doesn't it? It's going to be now. Please. This is just taking time. Let me close this and reopen. Guess I could also upgrade Excalibur as well on this computer. Community plugins, check for updates. Update. Kind of update all, to be honest. Here we go. Oh, it's showing up on screen now. Okay, recursive method. So you thought about it in terms of start at the root. You can pick either 1 or 10. But you can't pick 1 or 1. And then you can pick 0. No, you can't pick 0. You can't pick 1 anymore. But you can pick 1, 2. You pick 1 or 1, 2. And if you pick 1, 2, then you're done. if you pick 1, then you can also do 2. So the total number of different ways is 2. There's 2 different ways. I might make that a different color, maybe red, maybe green. Two different ways. Okay, so that is the recursive method. Now, subproblem method is going to be a little bit interesting, but since you can think about this recursively, then you can also think about this as subproblems, typically. Vishal, so what year are you in college? I am in kind of my 4th year. Technically, it's first year masters. But yeah, like straight after 3rd year bachelor's, I went into my masters. Now let's think about the subproblem approach, where Leetcode expressed it as, if you have 1, 0, 1, 2, how do you split it off? Well, if you start at some given I, no, you kind of have to keep the, say your dynamic programming array is initialized all to 0 or none, maybe. It's a good question. I don't know what you want. Think about it. The recursive method makes sense. The subproblem method, I need to find a way to express well. So I guess when you look at 1, so at what index are you at when you're doing this first branching? Well, you're at index 0 almost. And when you're at 1, you're at index 1. When you're at 10, you're at index 2. And so at index 0, you want to be able to find that the DP of let's see, so you could have then I at 3 and then I at 4, 0, 1, 2, 3. wait, 0, 1, 2, 3. So 0, you're going to just have 0 here. 1, 2, 3, and then you're going to have a 4. And this is I4. Okay. I'm guessing, wait, let me think. So what this I tells you is where you start to do the DP from. Where you start to do the DP from. From 10, you do the DP from 2, index 2. For index 3, you do the for 1, you do the DP from index 3. Of the dynamic of the DP array. Okay, so if I just make it clear to myself what the DP array is. So the DP array is equal to some empty initialized to 0 of 1, so 0, 1, 2, 3, 4. I'm going to say the index. Hello, Shah Jalani. Good morning, Rawat. I got it right this time. Got it right. Yeah. Rawat G. Calvin, what's the highest math class that you've taken in university? Probably for me it was like real analysis. Technically it was one called group theory and linear algebra. That's one subject. But I didn't finish it. I dropped out. So the most I did was real analysis. Aditya, hello man. Thank you. So I might just keep like 1, 0. Keep it the same color, maybe. Black. 1, 0, 1, 2. All right, catch a Vishal. So the calculations which need to take place are a little interesting. On the base case, you return 1, right? Right? Because there is only one solution there. So when you reach 4, technically when you reach 3, no, when you reach 4, I think it's when you reach 4. That's going to equal to 0. I'm going to open this up. If I go back now, okay, it does get updated. Damn. So maybe you do an if condition. You know, if yeah, I think this is what I need anyway. Fuck it. We're just gonna do the problem. I know how to do the problem. Drawing it out is a little harder to think about. But that's kind of what your setup is going to look like. We'll update it if implementation changes. All right, so we're going to set a DP array to 0 for length of string. Now, it's likely that we use length of string multiple times, so I'm just going to call this n now. Okay. Now we're going to do this. We can do this a top-down approach or a bottom-up approach. I'm inclined to first try and solve this problem top-down. I could use the recursive method right now, just to see what it's like, or just go to the DP array straight away. All right, let's just, since we're already writing DP array, let's do DP. So if let's have a look. We're gonna have to DFS, right? DFS something. starting from I, where I is equal to 0. Return, I guess you return the value in the DFS. So the DFS goes here. Likely. Okay. So the DP array, when you index I, if this is equal to 0, then you haven't dealt with the problem before. So you check the subproblems of I plus 1 and I plus 2. But the result okay. So all the different ways for all those to add them up, right? So you might have to add this up like this to get a result. Maybe this is what you return. That's only if the DP of I is equal, has not been processed at all. However, if it has been processed, if it's not equal to 0, then you return DP of I, right? Now, you can only DFS this if it meets certain conditions. If your current I is equal to 0, then you would return and do nothing. S of I is equal to 0, do nothing. If DFS I plus 2. Does that even make sense to me? Alright, I'm getting stuck on this. I might need to try the recursive solution first. Okay, so I'm gonna delete this Shall I delete it? I'll save it in the solution here. In the submissions, yeah. All right. And we'll reset. Okay. Recursive. Well, I know for a fact the recursive needs a DFS. Maybe you do start from I. If return result, where result is maybe we're going to say 0 to begin with, and you do a DFS of starting from 0. So if s of I is equal to 0, if s of I is equal to 0, I mean, if it does not equal to 0, DFS of I plus 1, if it is equal to 0 though, then you would return and do nothing. Right, let me see. So you have one, you almost start the DFS from -1. Or maybe you start from 0. S of 0 is 1, which does not equal to 0. So from 1 you can check if this I ever reaches len of s, and return then res plus equals 1, right? Minus 1. That's what I'm thinking. Or maybe it is just len of s. But this will be out of bounds, because if this is 4, then that won't work. So maybe you just got to return here. So DFS I plus 1 assuming that it's not 0, and check DFS of I plus 1. Which gives you some value. Possibly plus DFS of I plus 2, but why does the I plus 2 make sense here? If it does. 0 plus 2. What about 3 and 4? One, 1 is 2. And this is what you would return. You'd return 1. Am I convinced? I feel like you're doing too many things. Yeah, you are. So don't return 1. Don't return this. Break it off. You can only do this if this is equal, if this is not equal to 0. And you can only do that if the two numbers equals if this is equal to 0, then you can't do anything. You'd go to the next. But if it's not, then you would check if. Well, you know all the 1 digits will work, but the 2 digits might not. I plus 1 and I plus 2. If s of I plus 1 is equal to 1, the biggest confusion here is the positioning. Damn, I'm stuck. There should be a better way to understand this problem. I feel like I can understand it. Just give me a time to think about it. So let me think the recursive method again. I is 0 here. Is this I meant to be shifted at the very, very beginning, where it doesn't exist? So the point where it doesn't exist means I is greater than 0. Sorry, I is greater than or equal to 0. And maybe we start from -1. If we start from -1, now we're going to start at 0. Can't do anything from 0 afterwards, so you would just ditch it. So it's the first time that you see the 0 that you would just ditch it. If then you look at the subproblem of right, you ditch it. But if it's not being ditched, you check 1. Continue to check it if it's not ditchable, and then if I plus 1 so what that covers from 0 to 9, you're telling me? Then you're going to say 10, 11, 12. Less than len of s. And plus 2 could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I guess it's or. 2 and s of 1, s of I plus 2 is equal to, is less than 0, greater than, equal to 0, and si plus 2 is less than, equal to 6, then you would do DFS of this. Okay, that kind of looks okay. You start from DFS of -1. Oh. Res. Non-local res. Your output was 1 when you expect 2. Your output was 1 when you expected 3. Your output was 1 when you expected 0. So def print I. Res updated on given I. Res updated on 2. Res updated. It only got updated on the 2. Okay. Let's have a look recursively. Yeah, look, I started from here. Yeah. I'm going to keep this the way it is. Okay, so this conditioning is fine. And this should... Oh. Is it perhaps, not a string? So it's not a Okay, so I think I might know why. It's because this is a string value. And this is a string value. Perhaps. And this is a string value. And this is... You can't do string comparison on that. Well, I guess you can go odd, possibly. So you can go like odd of this string value is greater than odd of string value of 0. Odd of this string value odd of 6. Okay. I didn't mean to click submit anyway. Well, okay, that's giving us right answers, but the wrong ones here. 1 and 0 together gives 10. Now if you did 1 and 0, you'd have, starting at -1, this becomes not, you wouldn't continue with this, you wouldn't get there, and then this wouldn't work because that's not there. And then you would just do DFS of I plus 1, which is going to be from 1. So then if you do it from 1, 1 is equal to len of, no. Ooh. And is 1 equal to 0? No. And then DFS of I plus 1. That would mean it's now at 1. If it's at 1 now, len of s is 2. So you still don't get there, but it's equal to 0, so you'd return. Yikes. I'm not sure if this is going to be the right way, but what if we put that first? Yeah. Okay, solution. Then you increment. Yeah. It's interesting. Because kind of doing one more than required, right? So if we change this to +1, change this to that. Okay, so that should be correct then. String index at a range. Maybe I just gotta start from 0 here. Hello. Canal. Do you attend Univ daily? Not anymore. Right now, I'm on holidays. So I'm doing Leetcode problems. Oh. Here we go. I think that's why. Okay, well, the recursive solution works. Except we're not using dynamic programming, and that's what we want to use. This recursive solution is an O of n time and space complexity, right? O of n space, O of 2 to the power of n time, because you can have two choices. Okay. I'm convinced. Right. That's recursion though. And I did this recursively kind of funnily. I'm alright with that. So I will keep track of this though. Alright. Gonna put that here. Yikes. Submissions. Copy. Here we go. Alright, so we can mark this as recursion. And now let's try this in a dynamic programming way. So we re-clean all this. Oh, now I guess actually no, let's not clean all that. Let's bring this back. And we'll just try and make it a DP problem from here. So DP is going to equal to 0 times sum n, where n is equal to the len of string. And then the I need to see how it's done with the DFS. Does this make sense? Interesting. It's similar. It really is similar. But you remove result. You don't use non-local. In this DFS, we return the result of taking the result of these. Result is whatever DFS is. This will always be true anyway. Let me remove this. And you return, technically you return 1. And then you would not use DP at all, right? That makes it so you don't even need a DP there. And this would be the solution where the result is within the correct, is just passed in. So I'll make this better. Recursive with return statements. Python. Oh, just do it from here. Recursive with return statements, which means that the DP solution is pretty straightforward addition, whereby fuck. DP of the very last value, n minus 1, is equal to 1. Is that right? So my thinking is then, if dp of I is equal to 1, you return 1. Otherwise, you would return 0. Like, if this is equal to 1, then it should just return 1. How does dp ever get updated? dp of I is equal to result. Does not equal to 0. Am I convinced? Because it seems to me that it can only ever be... Okay. If I in... So I is less than len of... n, and this. Yo! It's kind of difficult. Let me undo this. It always returns 1. Yeah. Okay. This though is meant to return dp of I. Oh! That changes. Doesn't make a difference. Okay. Undo. The problem then is that this has to be not equal to 0. Returning 0, returning dp of I Damn. Okay, why is this failing? dpi does not equal to 0. Still getting the same response. It's 2. Oh, yeah, where are we putting stuff in the DP actually? Maybe we gotta put it at the end position. +1. Shoot, man. That was unexpected. Let me think. Do you really need to do this? You don't. You don't really need to do that. You know, that means then, is this not simply going to be, if this is equal to 1, then you return 1. Yes. Okay. Very interesting. Because that means that you don't really need a DP at all. If anything, we've just built out this DP for fun. So this DP finally is, we can kind of print what the DP looks like. At each point. Yeah. Yeah, let's do the printing the DP at each DFS. So for 12, at 2, at I guess you can print it after, right? Maybe that's what you need. Because when it's originally, it would originally be at... Wait, let me undo. Undo. This would all start from oh. It's not. Oh yeah, it's starting from just a 1 being there. That's right. Right, and then let me make that DP there. Run this. Oh. I mean to put it here. Even in Kasahara. So that's right. I guess we can also print what the DP looks like originally, just to give ourselves an idea. Print of this DP before we do anything and when we do stuff. Yeah, okay. Well, you know, this tells me that you return 2. What else does it mean though? Okay. It means that when you're only considering nothing, it's going to be 1. No. If you consider 2, oh fuck, what does this array representation even tell me? If you consider 2, then your one that's in the DP means wait 0 1 2 0 1 1. Index 1 is 1 1. That means when you're at 2, you only have 1 possibility. When you're at 1, you have 2 possibilities. It's basically the output of the DFS. 0 possibilities, 2 possibilities, 1 possibility, 1 possibility, 1 possibility. I agree. That means, let me go back to this drawing. I might rub this out. Okay. Wait, should I? No, I shouldn't. Because is this a literal reflection of what we're talking about here? These base cases will always be 1. Your DP array originally is 1. That's right, so these should match. Okay, yeah, all right. So look, this will tell me dynamic programming top down approach. Python. Let me submit this first also. Runtime error. I'm basically going to say it's because you put these print statements here. That's the reason. So we can copy this, paste it. Print DP. Same to print DP here. For the input of shit. For these inputs, I guess you can say bash. No, text. S is equal to 12. I want to say 1012. Oof. And I got to create a test case for it. Oh, print dp, print dp. Technically I could go like initial dp. Like that. No, that kind of looks shit. Keep it clean. Copy that output. Paste it here. The top-down approach here is only useful for keeping a dynamic programming, a DP output, I guess. In reality, this problem is an extension from the recursive approach. If you look closely. Yeah, okay. You can kind of think of it as like iteration 1, iteration 2, iteration 3. Or you can think of it as, I guess, when you update the DFS. Okay. Something like that. And then we're going to also try the bottom-up approach to this problem. And then finally the space-optimized approach. How do you reference headings? In Obsidian. I see. So this note dynamic programming top-down. Next section. G'day, Nahi. Hello, man. I'm about to have dinner. Unfortunately. Caught me at a wrong time. I'm gonna have dinner now. Come back to finishing this problem after dinner. Alright. So we'll pause it here. I'll be back. Alright. Catch us in a bit. Guy you can trust. Hello, man. Was able to get a memoized solution working in C and hit submit. Very surprised that runtime was 0 milliseconds on my last submission. Doing something identical was 19 milliseconds. Are you sure you're not a culprit of the Leetcode 0 millisecond runtime problem? Because that seemed to be a thing for a while. Don't know if it still is. Now I'm just putting back my camera. I will try and solve this problem ASAP. At least the space optimized one, because I want to go have a walk a little bit. Let me turn on my camera. Hello. Let me turn on the lights. Okay. Okay. Okay, dynamic programming bottom up. All right, let's just try and understand why this bottom up is different, and then try and implement it ourselves with our own. Now the bottom up requires just a for loop. Interesting. So, you know, looking at this, you go in reverse order. If Si is equal to 0, dp of I is 0, else it's not 0, and so dp of I is equal to dp of I plus 1. If I is between there, and then dp of I is equal to, is plus equal to dp of I plus 2. And you return dp of 0. From my understanding then, is that instead of DFS, you put for I guess, yeah, for I in range of n minus 1, minus 1, minus 1, dp of I is equal to this, okay. So this becomes here, else we get a dp of I plus 1. This gets removed. Oops, I mean, it's kind of just a dp dp of I. You could go continue, right? Yeah, you should go continue there. Do this out here. This dp of I. So it's originally this. And then dp of this. And then you return dp of 0. For sure. I mean, this is definitely much simpler. Might copy it from here. If you ever see 0, then it's always going to be 0. You know, that is a key point. That is a good key point. It is worth noting that when s of I is equal to 0, then dp of I is equal to 0. For sure. All right, and then finally, the last optimization is dynamic programming with O of 1 space. Instead of keeping a dp array, you could use just 2 variables. Now, how you do that is a good problem. Is a good question. Let's have a look. Shanat Boon Chan. Keep fighting, you are next tourist. Bro. Wait, I can't tell if that's a compliment or a diss. Okay. dp2. Alright. I guess, you know, instead of 2 arrays, I kind of just want to make the dp into 2 variables. Kind of seems cooler. Keeps the idea of a DP. Okay. Now DP1 though, you're telling me that's meant to be 1. And then you're telling me that DP is 0. Oh. It's like temp variable. Can I just call that a temp? Or should I literally just put it within here? Perhaps I will just put it within here. So it's DP of 0. Zero, 1, 0. DP of 0, 0. DP of 1. No, DP of 0 is DP of 1 and then DP of 2 and then the extra step is to update the DP pointers. By shifting everything. So it's like adding 0 plus DP string slice that 2 or string slice that 1. String slice that 2, including 1. Rishu Singh, why is YouTube recommending me this? Let's see. No. Anakul. Keyboard coded, but mouse is the clown. For real. And it's all 0, right? Yes. Oh, right. Because you want to return one. Okay. Something's cooked here. Yeah, something's cooked here. Let me go back, I'll look at the solution. You don't need this anymore, I guess. If you just do it here. Fuck it, we keep it. Zero, one. Now this is the DP of 0. One, 0. You continue. You increment again. If that is all fine. And then you set a new DP where you slice it by DP of 2. Is that right? I kind of got to just double check it here. Fuck me. One. Well, why don't I just print the whole thing also? Why is that a different color? Does that mean something? Does that mean something? And for sure that this should be right. Whoops. That is right. If you write recursive solution first, it becomes easier to convert to bottom up. Fact is, like, I did, and then I converted it to top down, and then now I'm converting the top down to, I converted it from top down to bottom up, and then now I'm converting it to an O1 space. So I'm at the very last step now. I guess it could be this. No. There's something I'm missing out of this, so I'm just going to have a look here, compare between the two. You only need 3 variables. DP, so 0, 1, and 2 is 0, 1, and 0. And looking at this solution, 0 is 0, else you equal to 1. In this case, you can also just think of it as continuing. Fuck. Maybe I'm overlooking this. I overlooked it. Man. That's a rip. Now, why would that be the case? You would completely not go through this step if you make this equal to 0. So if this is 0, then you would never reach this step. Because before it was a continue. But how does that cause it? How does that cause a problem? Perhaps it's because this never gets updated. So yeah, okay. It's because this line should also happen here if you're continuing. There we go. Okay, so fine. That makes sense. But, you know, the important part here is really just this line. Okay. Oops. Okay, this is the important line. I kind of got to make a highlight of this. Shift the dynamic, shift the memo window. Yeah, it's kind of like a memo window. Instead of keeping a DP array, you could use just 2 variables, or just a window of the DP array. So, you know, this same thing applies here. It's the important part. Okay. And yeah, this is notice this is constant size DP. Okay, variable size DP. Yeah, so that makes sense. So, like in general then, to convert a dynamic programming array to just a fixed dynamic programming problem, or an all of one space complexity dynamic programming problem, you can probably formulaically do this. And then I think that's cool, and I might want to take note of that. So Vishal, what is dynamic programming, and why is it important to know how to implement to solve a problem, and when to know it's a DP problem? That's a good question. Okay. What is dynamic programming? It's, for me at least, my understanding of it is given a memoized, given a function, that function should take into account, no, wait, no, let me try and phrase this the right way. In dynamic programming, you have memoization, which is represented as some function, some pure function that takes an argument as input and returns the cached output. And it's the cached output because you save previous computations into that pure function. Okay, so that's a little confusing still. I can't even, if I, like, even me saying it out loud, I feel like if you heard it the first time, you wouldn't understand what I'm trying to say. So, I feel like there's an easier way to say it though, right? It's basically making computationally expensive function calls it's basically saving the computationally expensive function calls so that they can be used in future function calls. Also, they can be used in future function calls. There's a distinction there, though, that I have to make when I'm saying function calls. But I hope that gives an idea. So it's the ability to save computationally expensive outputs and use those outputs I think that's all I can say. All right. And I hope, like, I mean, why is it important though? It's important mainly, yeah, I mean, for computationally expensive stuff, but also more semantically for my situation, it's because Google interviews will have these dynamic programming problems, obviously. And they're known for having dynamic programming problems. To know when it's a DP problem though, you kind of have to know that you're dealing with subproblems. I mean, even for this scenario, you might have, say, you know, you had like a recursive approach to solving this using backtracking. Then thinking that, okay, maybe if you can do this backtracking, then you can also do this using dynamic programming. That's my thinking. And, you know, obviously that's what we did. We did recursively first, then did a top-down dynamic programming, then bottom-up, then the most optimized dynamic programming solution. I don't think that dp00 equals 0 line is necessary, since dp0 is always 0 in the beginning of the for loop. Okay, no, you're right. You're right. You're right, actually. Let me see that. Yeah, you're very right. Thank you. ABCD DCBA. We can apply DP if 1, there are overlapping subproblems, and 2, optimal substructure. I see. Yeah, overlap, okay. Now, what you mean by overlapping subproblem is interesting to me, like overlapping subproblem. I might have to search that up. And optimal substructure is another thing. Okay. I'll keep a note on these terms. Got to keep a note of these terms so I can better explain this stuff as well. Okay, however, you know, final verdict. That's not a final verdict. Final insights, all right? Because we've been doing this pretty much most of the day. Honestly, it's probably been a lot of hours spent on this just one problem. But converting from recursive to top down, DP is relatively easy and requires almost no call to the DP array except at the base case. Yep, and then converting from top down to bottom up requires converting DFS to a for loop, a reverse for loop. Then converting bottom up DP requires, bottom up DP to space optimal bottom up requires converting DP of 0 times n to DP of 0, 1, 0. Yeah. Changing all instances of the DP call. And then, yeah, no, that's all it is. It's just this. Okay. That's it. That's the final understanding. Cool. I'm going to understand this another day though, like the overlapping subproblem and optimal substructure ideas. Maybe it doesn't need to be on another day to understand, but look, we've spent quite a lot of time today on this problem. Let's finish it off with just putting this into my Leetcode repo. 91 decode arrays. I spent a lot of time understanding how to go from recursive approach all the way to space optimal dynamic programming approach. Okay, git commit git push. Okay, tree maze. Yeah, so this is kind of like a decision tree, 1D dynamic programming. All right, well, we got through all 4 of those solutions. Pretty good. Yeah. Zero millisecond runtime as well, bug. Very nice. Okay, that's it, guys. We're gonna call it a day. I'm gonna go for a walk before just chilling tonight. Vishal, recursive approach to space optimal dynamic programming approach. Okay, git push. Yeah. All right. I'll catch you guys tomorrow most likely and do another dynamic programming problem. Thanks for joining, guys. Appreciate you. Peace.